Hello, this is Jack Jackson. We're going to start a series of videos here talking about polynomial relations. They're all going to come from this same set of notes. So if you're following these notes along, you'll see what the basic videos are going to be about. And so we're going to start with some introduction and terminology about polynomials. So a polynomial consists, as an expression, it consists of terms. Each term consists of either a single constant, in our case, say real numbers, or the product of a constant and variables to constant natural number powers. These constants are called the coefficients of the terms. The terms are then added together to produce the polynomial. Notice that negative and fractional powers are not allowed on the variable bases. Variable powers are not allowed. So, however, any real number, including, ones with radicals and irrational numbers and all kinds of things, can be used as coefficients. So the first exercise is see which one of these are polynomials. And we could go through here and circle some of them. Well, this is a polynomial. This one's fine. This one's not, because of the x in the exponent. This one's not, because this will be an x to the 1/2. This one's okay. The square root on the constant's fine. A constant term is a polynomial. That's a polynomial. This is a polynomial, and this one is a polynomial. So we can see some polynomials there. Okay, some more terminology. The degree of a term is the sum of all the powers on the variable bases. The degree of a polynomial is the maximum of all the degrees of the terms. So we're going to see how many terms we have. Here, the terms are separated by the adding and subtracting. So here we have 4 terms. Each coefficient here, there's a coefficient. I'm going to think of that negatives going with it. So I'm going to think of it as plus a -7. So the -7 is the coefficient. There's a coefficient, 16 and 7. So the coefficients are 13, -7, 16, and 7. The degree of each term, this has a degree 10, because you add those powers up. Add these powers up to get 11. Add these up to get 13. And if it's a constant term, it's degree 0. The biggest of these will be the degree of the polynomial, which is 13. We have some special names for some really smaller polynomials. If it only has one term, it's called a monomial. Remember, mono is 1. Bi is 2, so 2 terms is a binomial, and tri is 3, so 3 terms is trinomial. You could talk about quadrinomials and pentanomials or whatever, but usually, once it gets beyond 3, we'll just say something like a polynomial with 7 terms. We usually prefer to write polynomials in decreasing order, not always, but often. And this refers to writing the terms so that the degree of each term is decreasing. And this is especially when there's only one variable, we'll do that. So like on A here, we would write this in decreasing order, would be -4x to the 5th plus 3x cubed minus x squared plus 2. When you have 2 variables like an x and y, we usually let whichever one comes first alphabetically, let it decrease in power and let the other one increase. So all of these have degree 2 terms, but we would write it in, we would call this decreasing order. -14 x squared plus 3xy plus 2y squared. This, when you put it in decreasing order, that first coefficient is called the leading coefficient, and that first term is called the leading term. If the leading coefficient is 1, it's called monic. So, x squared plus 3x plus 2 is monic. 2x squared minus 3x plus 7 is not monic. That coefficient of 1 is what makes it monic. If it's first degree, we call it linear. 3x plus 1 is degree 1, and that's called linear. Sometimes we can use properties of distributive property and combining like terms to simplify some polynomials. So let's try this with a few examples here. Here we can use a distributive property to make this 6x plus 9. Here we can use a distributive property. Let's see, 3x cubed minus 4x squared. Distribute here. So this is plus 2x squared plus 8x cubed minus x squared. And then we combine like terms. 3x cubed and 8x cubed combines to be 11x cubed. Negative 4x squared minus 1x squared is negative 5x squared. And, oh, we also have a 2 more x squares, so that makes this negative 3x squared. So we can combine and simplify. That's a lot simpler than the original. I'll do maybe one or two more here. So this one is 3. Work inside the parentheses first. 3 times 2x. Distribute the 4, so this is 12 minus 16x plus 2x. Then distribute the 3, 6x. Well, actually, you know what we should probably do? Actually, we have all options. We can distribute first or simplify first. I'm going to actually simplify what's in the bracket first before going on. So this is negative 14x plus 12. Then I'm going to distribute 6 times that. Okay. 24, 6, 8, negative 84, 72, 2x. Combine like terms here, negative 82x plus 72. And so that simplifies a bit. And you can do similar things for these other exercises. So I'll leave those for, I'll leave some of those for practice. We can also use some of our properties of exponents to, now right now this is not a polynomial because of that negative 3, but our answer might be. So here we have 5 and an 8. Those are just multiplied, although we normally don't write it like that. I think what I meant was here something else. I think I actually meant, let me change this. I think I meant for this to be a power. Okay, and if we do that, our answer will be a polynomial. So we got 5 times 8 is 40. X to the 5th times x to the negative 3 is x to the 2nd. And y to the 4th times y to the 3rd is y to the 7th. So we've talked about properties of exponents. And the resulting thing is a polynomial. Here we can raise each thing to the power. Here, so some properties of exponents. Use those. And 4 squared is 16. X to the 5th square is x to the 10th. And this is y to the 14th. And we've seen some other properties here. I'll leave these to you for practice. Now we can multiply polynomials with the same algorithm we use to multiply multi-digit natural numbers, and it works for the same reason. It's because of the distributive property. So we can take the 3 times the 2 is 6. 3 times the 3 is 9, but it's really 90. 3 times 1 is 3, and I'm lining up hundreds, tens, and units. I can take the 2 times 2, which is 4, but it's 4 tens because this is really 20, so there's a 0 for a placeholder. 2 times 3 is 6, and that's hundreds, and 2 times 1 is 2 is thousands, and then I can add up the units, the tens. In this case I have to regroup, and then add up the hundreds. In this case I'm regrouping again, and the thousands. Okay? We do a similar thing over here when we're multiplying polynomials. We take we put them in decreasing order first. It makes it a little bit easier. And then multiply the 5 by each one in the top. 5 times negative 7 is negative 35. 5 times 2x is 10x. And 5 times 3x squared is 15x squared. Okay? So next, I take the next one down, the negative 3x multiplied by 7, and it's positive 21x. But notice I line it up here with the x's, with the x terms. Negative 3x times 2x, by the way, notice I'm bringing the sign with it there. Negative 3x times 2x is negative 6x squared, and I line that up under the x squares. Negative 3x times 3x squared is negative 9x to the 3rd, and now I've made a new column for my x cubes. Now, the next one I take the 4x squared and multiply by each. 4x squared times negative 7 is where I got the negative 28x squared lined up under the x squares. 4x squared times 2x is 8x cubed here. And 4x squared times 3x is 12x to the fourth. Now I've already got everything lined up. I'm adding all this together, and so I'm lined up like terms and add that together. Negative 35, this is 21x plus 10x is 31x. Let's see, you put all that together, that's negative 19x squared. Yep. And this is negative 1x cubed and 12x to the fourth. Okay, so let's do these. So notice xx, or x times x, is x to the second power. X plus x is 2x. Okay, real basic. If we just have this, we can use the distributive property to multiply out. Negative 6x squared plus, let's see, we got a y cubed. And 6 times that is 12, carry 1. 6 times 8 is 49, I believe, when we add that together. Here we can distribute the negative 1 minus 2x plus 9y minus 1 and combine like terms to get 6x plus 14y. We'll put our constant term last, plus 1. Okay, so now we're going to actually do some multiplication here. And so we could do this. Well, we have shortcuts we've looked at in an earlier video for this. This is 15x squared minus 2y squared. That's 225x squared minus 4y squared. We can use our shortcut of FOIL here, which is really just, we could do this with the long multiplication too, the same algorithm. Okay, as we're multiplying these out, we're going to get 4 things, but we can also do it with FOIL. So this is a to the fourth, the last negative 30, b to the sixth, and the two middle terms are going to be 6a squared b cubed and minus 5a squared b cubed. When you add those up, you get plus 1a squared b cubed. Okay, let's go down here. How about the next one? X squared plus 2x plus 4. Whoa. Let me change pens. X squared plus 2x plus 4. And then we're going to multiply by x minus 2. Negative 2 times 4 is negative 8. Negative 2 times 2x is negative 4x. Negative 2 times x squared is negative 2x squared. X times 4 is plus 4x. X times 2x is plus 2x squared. And x times x squared is x cubed. And this time these middle terms cancel out and you get x cubed minus 8. So that's going to be a very special one there. Where was that? Here it is, x cubed minus 8. And so forth. So I'll leave those to you for more practice. There's several examples that you can work out there for practice. Okay, so the same long multiplication algorithm, or the algorithm that we use for multiplication of natural numbers, it's basically the same for multiplying for polynomials. This talks about FOIL, which we covered in our quadratic video as well. And then we talk about a trinomial square. So those are special products, and this is using some of those special shortcuts. So we'll come back in our next video and talk a little bit about dividing polynomials. So we've established in this video some basics of terminology for polynomials, how to combine like terms, and how to multiply polynomials.